So in this video, we're going to look at arithmetic series. So if you haven't checked out already arithmetic sequence, it's worth looking at the video on linear arithmetic sequences first. The difference between an arithmetic series and an arithmetic sequence is this. A sequence, what we've come across before, is say 1, 5, 9, 13, and so on. This is an arithmetic sequence because it's a sequence of numbers, and it's arithmetic because it's going up by 4 each time. Series, however, is when we are considering the sum of that sequence. Okay, in other words, we're adding all the terms together. So in the log tables, the important formula that you have here related to arithmetic series is Sn equals n over 2, 2 times a remember is your first term, plus n minus 1, d remember is your common difference, and that will give you the sum of a particular number of terms in a sequence. So for example, say you wanted the sum of the first 4 terms in this series, then 4 is obviously your n, and you're getting basically 1 plus 5 plus 9 plus 13, what those 4 terms add up to. Obviously, it's easy to add those 4 terms up without having to put them into this formula, but say I was looking for the sum of the first 100 terms of this series, then it would be much more laboursome to add up all of those 100 terms. What we would do then is sub in 100 for n, a is your first term, which would be 1, and d is the common difference, which we figured out up here is 4. All right, so we're going to go through a few different types of questions, all of which are going to involve the use of this formula here that is given in your log tables. All right, so let's try a question. Okay, so take a look at this question. We have the series 4 plus 11 plus 18 plus 25, and I want you to find two things: an expression for Sn and then S20, or the sum of the first 20 terms is another way they might ask this. All right, so the formula you have to work with here is your sum of a series formula. If you feel confident, pause the video and see how you get on with this. Okay, so what I'm going to do first of all is get an expression for Sn. So the two important things I need here for this, to fill in here for this, is A and D. And A, of course, is the first term, which is 4, and D is the common difference. So we can see what's going on from each term is it is adding on 7 each time. So D is 7. So an expression for Sn, obviously if I want an expression for Sn, I'm leaving it in terms of n, so keep n as n throughout. 2 times A is 2 times 4, plus n minus 1 times 7. All right, so let's simplify this up a little bit. We get n over 2, 2 times 4 is 8, plus, and multiplying this out, we get 7 times n is 7n, and 7 times minus 1 is minus 7. Okay, tidying up a little bit further, I can add my numbers together. 8 take away 7 is 1, so 1 plus 7n, and there is an expression for Sn. All right, if I was to go a little bit further with that, although there would be no need, but n over 2 times 1 is n over 2, and n over 2 times 7n would be 7n squared over 2. It just in case it was given to you in a different format on, say, for example, the paper. But both of those are equivalent, and both of those are therefore your expression for n. Okay, so the second thing that they've asked us to do is find an expression then, or sorry, find a value then for S20. So now we have a value for n. You also know your value for A, and you know your value for D. So you could go straight ahead and fill it in to the original formula. Or since I have already done a bit of work on tidying up the formula, I can sub it in to here either. I'm going to go back and sub it into the original. It's something I would suggest you do in an exam paper question as well, just in case you've messed up on the simplification of this in some way. All right, whereas this you're given in the log tables and you know you won't go wrong. So instead of n is 20, 2 times A is 2 times 4 again. N minus 1 this time is going to be 20 minus 1. and times d, which is times 7. And now we just need to evaluate all this. 20 divided by 2 is 10. 2 times 4 is 8. 20 minus 1 is, of course, 19. And 19 times 7 is what I'm going to do next. And that gives me 10 times 8 plus 19 times 7 is 133. And evaluating that, then we get 10 times 141, which is 1,410. So the sum of the first 20 terms in that series is 1,410. Okay, try this question. So we have 1 plus 5 plus 9 plus 13, plus 41, and we're being asked to find the sum of the series. So we know straight away it's got something to do with this formula. I want the sum of the series, but I don't know how many values I have here. I don't know what my n is. I know what my a is. My first term is 1. I can see what my common difference is. It's going up by 4 each time, so it is a common difference of 4. But I don't know how many values I have. I just know that this last value is 41. So what I'm going to need to do here is find out what term that is. If I know what term that is, I know how many I need to add together. So if you go back to our nth term formula that is in our log tables, this is going to help us out here. I know that this particular term has a result of 41. I just don't know what term it is in the series. So if I know it is 41 and I know the first term is 1, obviously I don't know what the n is yet, but the common difference I know is 4, then what I have here is, when I multiply this out, 4 times n is 4n, 4 times minus 1 is minus 4, add together your number work and we get 1 minus 4 is minus 3. So 4n minus 3 on the right hand side is this tidied up. And if I solve this equation, then add 3 to both sides, what I end up with is 4n is equal to 44, and divide both sides by 4. I have n is equal to 11. So it's the 11th term. Okay, so now I know I want to get the sum of these 11 terms. So it's 11 over 2. 2 times a, which is 1, plus 11 minus 1, d is 4, sub everything in, and we will get 2 times 1 is 2, plus 10 times 4. That works out to be 42, and 11 over 2 times 42 works out to be 231. So the sum of those 11 terms is 231. So watch out for questions like that, where you know the result, you just don't know what particular term it is. Then don't forget we can always use this formula here in a log tables. This is the nth term formula. This is the sum of the series. Okay, so try this question. So in this question we're getting the information that the fourth term of a particular series is 15. The sum of the first 5 terms is 55, and we're being asked to find the sum of the first 10 terms of that series. So 2 pieces of information here, and here obviously are our 2 relevant formula. We have our nth term, which is what this is going to help us fill in a lot of information into, and we have our sum of a series formula. So again, we will use the information we are given here and sub it in as best we can in here as well. Okay, so the fourth term is 15. So that means that n is 4. This should all result in 15. A we don't know. N is 4, as I said, and D we don't know either. Okay, so simplifying this up a little bit further, I end up with 15 is equal to A plus 3D, and that's as far as I can go with that. So let's now sub in this information into here. So n is 5, and this all should result to be 55. So 55 equals, n as we said is 5, so 5 over 2. 2 times a, I don't know what a is. I do know n is 5 though, minus 1, and d I don't know either. Okay, so I'm going to try tidy this up as best I can. I've got 55 here equals 5 over 2, 2a plus 4d. All right, I don't want to have to multiply in by this fraction or 5 over 2, just 2.5. I don't want to have to deal with that. So what I'm going to do is multiply both sides by 2. So if I multiply that side by 2 and I multiply that side by 2, that's all one term, if you like, because that 5 over 2 is being multiplied to this. So the minute I multiply this whole side by 2, that will get rid of that denominator of 2. Okay, so I end up with 2 times 55, which is 110, equals, and then what we're left with is 5 times 2a plus 4d. You do not have to multiply this by 2 and then this by 2 as well, because this is being multiplied to this. It is one term already, okay? They're not two separate terms. They are attached because they're being multiplied, all right? So once you multiply this by 2, you get rid of the denominator of 2, and then all you're left with is 5 times 2a plus 4d. And then tidying that up, I get 110 is equal to 10a plus 20d. And that's as far as I can go with that. So now what you see I'm left with is 2 equations with 2 unknowns, a and d. So we will now solve them simultaneously. Okay, so the best thing to do with these two now is I'm going to eliminate the a's. I'm going to multiply that top line by a minus 10, and then that will give me a minus 10a up here, which will cancel quite nicely with the 10a below. So minus 10 by 15 is minus 150, minus 10 by a is minus 10a, and minus 10 by 3d is minus 30d, and 110 equals 10a plus 20d. Okay, and now we are going to add these together. Minus 150 plus 110 is minus 40, they cancel, and minus 30d plus 20d is minus 10d. Divide both sides by minus 10 and I get a positive 4 for d. So my d is 4. Let's take this then and sub it back into one of my originals. I'm going to take d is 4 and sub it back into this top one. And I get 15 is equal to a plus 3 times 4, which is a plus 12. Take away 12 from both sides and I'm left with a is equal to 3. So now if I go back to my question, the sum of the first 10 terms of this series, I know n is 10. I'm going to sub it in. I'm just going to write it out in its general form first so you can see exactly what I'm subbing in to where. So S10 is going to be 10 over 2. 2 times a is 3. We figure that out here. Plus n we know is 10 minus 1. And d we now know is 4. Okay. So let's evaluate this further. 10 divided by 2 is 5. 2 times 3 is 6. Plus 9 times 4, which is 5. 6 plus 36, which is 5 times 42. And 5 times 42, 210. So the sum of the first 10 terms of this series is 210. Okay, try this question. If I tell you that the sum of a series is given by the following expression, n squared minus 4n, find an expression for tn, the nth term. So if you feel confident with this, pause the video and see how you get on. Here what we're going to look at, obviously tn is equal to a plus n minus 1d. So what we need for this is a and d. They're the two pieces of information. We obviously need it in terms of n. We want the nth term. So the two pieces of information we're looking to fill in here is a and d. A being the first term and d being the common difference. Well, let's have a look at what I have. I have an expression for the sum of a series. So a series is when you have your values and you're adding each of those terms and the sum of these is what will be given by n squared minus 4n. Well, straight away, S1 is going to be the sum of the first term. So S1 will give you the first term. So subbing in 1 then into my expression 4n, I get 1 minus 4, which is minus 3. So I get that that first term is minus 3. Because when you add only one term together, you're still going to be getting minus 3. So straight away, I have A. A is minus 3. Now, if I want to know what the common difference is between this one and this one, then it would just be very useful to know what that second term is. Well, if I do S2, S2 isn't going to give me that second term. It's going to give me these two terms added together. So let's just see what that is. Subbing in 2 for the n, I get 4 minus 8, which is minus 4. So that means this term and this term is going to be minus 4. Well, minus 3 and that term there is going to be minus 4. That means that that term there is minus 1. Because the two terms, the sum of the two terms added together is minus 4. So now I know that it goes minus 3 and then the second term is minus 1. The sum of those two terms is minus 4. The common difference, well, what is it going up by? I can see quite clearly then the common difference from minus 3 to 1 is an add-on 2. So now there are the two important pieces I need for my nth term formula. So subbing that in now, Tn is equal to minus 3 plus n minus 1 times 2. I'll multiply this out and I get minus 3 plus 2 times n is 2n and 2 times minus 1 is minus 2. So Tn is equal to 2n minus 5. Okay, so the last element to arithmetic series that I want to cover is sigma notation, okay? And sigma notation is the use of this symbol here, which means the sum of, okay? And obviously this can come up here in arithmetic series because with arithmetic series, we're talking about always the sum of terms in a series. So basically, here is an example of sigma notation in action. Say you are given something like this, all right? All I want to do here, first of all, is explain exactly what this means, okay? So this means that I want the sum of the terms from 1 to 8, where each of the terms would take the form 4 times whatever the r is minus 1. So, for example, the first term would be 4 times 1 minus 1, which would be 3. And because we have this sigma notation, we want the sum of all these terms, so then we would be adding. The second term would be when r is 2. So the second term would be 4 times 2 minus 1, which is 7. And then obviously we'd be adding for the next term. And we would have the third term would be when you would sub in 3. 4 times 3 is 12, minus 1 is 11. And you would do this up until the final term, which is the 8th term. And to get the 8th term, it would be 4 times 8 minus 1, which of course, 4 times 8 is 32, minus 1 is 31. Okay, now that is it laid out for you. That is basically what this notation means. Long-winded, this is the way it is. This is the way it is in number form. This is the way it is as you would work out each of the terms. But to simplify that, I could write it like this. from the first to the 8th term, I want you to add the sum of these terms, and each of the terms is given by this expression, 4 times or minus 1. Okay, so 4 or minus 1 is an expression for the nth term, if you like. They're just using the letters or here to denote what values you're going to take each of the terms to be. So for the first term, you're subbing in 1, second term 2, and so on. So if you were to ask to work this out, you have the option of doing it out the long-winded way. There's only 8 terms, but say that was 18 or something much higher, then you really would want to fall back onto your sum of a series formula. Okay, so we'll do it this way. That's obviously the way you would do it if you were to evaluate all the terms out. You would have to obviously evaluate all the ones in between there, but you could do that if you wanted to. It is going to be possibly a little bit longer, especially with 8 terms, or definitely if you've got more than 8 terms. But if I want to use the formula, all I need to know is what is my A and what is my D. I know what the N is. There are 8 terms, so N is 8. So you would want to evaluate a few of these to figure out exactly what the first term is. So obviously subbing in 1 will give you the first term. So we already know that now. We know A is equal to 3. And the common difference, well, we need to evaluate the second term to see what the difference is between the 2 terms. So I can see from 3 to 7, the common difference is 4. So now I have enough information. The sum of the 8 terms is going to be 8 over 2. 2 times A is 3 of course, plus N of course is 8 minus 1, and D is 4. So evaluating that, I'm getting 4, 6 in the brackets, plus 7 times 4. This is working out to be 6 plus 28, which is 4 times 34, which is 136. So the sum of those 8 terms is 136. Okay, last question. Try this. Again, we've got the sigma notation here, and I'm asking for what value of n is the sum of this series 90. Okay. So pause the video and see how you get on with this. If you need a little bit of help, play for a little bit maybe, and then pause and see if you can finish it off. Otherwise, if you're really stuck, watch through to the end as I explain it as we go. Okay, so what do I need? I need to figure out what value this n is. But I know that the sum of this series is 90. Okay, so Sn is obviously n over 2, 2 times A plus n minus 1d. So what can we fill in here? We know that it's 90. We don't know obviously what the n is. And we don't know the A or the D yet either. Okay, so that's what I need to start filling in here first of all. What is my A and what is my D? So let's go back to what information I have here. I know it's going from r equals 1 to something. So straight away, in order to get the first term in this particular series, I would sub in 1 for r. 3r minus 5 is basically your expression for the nth term. So the minute you sub in r as 1, you're going to get your first term. So 3 times 1 minus 5 is minus 2. So therefore, the first term is minus 2. In other words, A is minus 2. So in order to find the common difference then, well, if that's the first term, all I need to do is find the next term and analyse what it's going up by. So if I put in r is equal to 2 into 3r minus 5, I'll get the second term in that series, which is 6 minus 5, which is 1. So the next term up, if you're going from minus 2 to 1, what is that a difference of? Well, you must be adding on 3. So D, therefore, is 3. So now I have my 2 pieces of information that I can sub into here. So 90 equals n over 2, 2 times A, which is 2 times minus 2, plus n minus 1, and the D I now know is 3. All right, so what I need to do now is simplify this up as best I can and solve then this equation for n. So here's what I'm going to get. 90 equals n over 2. 2 times minus 2 is minus 4. Plus, I'm going to multiply this out. 3 times n is 3n. And 3 times minus 1 is minus 3. Again, I'm going to simplify my brackets. And I can add together my number work. Minus 4 minus 3 is minus 7. So I'm left with 3n minus 7. 3n minus 7 in the brackets. And like I did before, I don't want to have to multiply in by an n over 2. I don't want to have to deal with fractions. So what I'm going to do here, because it's an equation, I'm going to multiply both sides by 2. And by multiplying both sides by 2, I get rid of that denominator. And remember what I said before, you don't need to multiply that 2 in twice. Because that n over 2 is attached to the 3n minus 2, it is one term. So multiplying by that 2 once is enough to get rid of the denominator of 2. So then what I have is 2 times 90 on the left-hand side is 180. And I have n then bracket 3n minus 7 left on the right-hand side. So multiplying that out, I get 3n squared minus 7n. Now, if you spot what we're getting here, we have a power of 2, so it's a quadratic. So with a quadratic, obviously I'm going to have 3 terms. Let's bring it all over to one side. So subtract the 180 from the left hand side and therefore minus 180 from the right hand side. I'm left with this trinomial quadratic. So 3n squared minus 7n minus 180. So I need to solve this, and then I'm going to get my value for n, or in this case 2 values for n if I've got a power over 2. So let's see what I get. You have 2 options always with solving a quadratic. We could use the minus b formula, or we could factorize it. Okay, this does factorize quite nicely. So I always do the 4-step method for factorizing. So my first step is multiplying the first term by the last term, and 3 times minus 180 gives me minus 540. Then I need to find factors of minus 540 that would add together to give me a minus 7n. Now, if I know this is quite large, as I said, you've always got the option of solving this quadratic with the minus b formula, or work out your factors. This is, as I said, going to work out quite nicely for you. So what we end up getting, factors of 540 would be 27 times 20. And the signs that would multiply to make minus 540 and add together to make minus 7 would be minus 27 plus 20. Okay, so they're the 2 values I'm going to use. So rewriting out my quadratic, I get 3n squared minus 27n plus 20n minus 180. And so that is replacing my minus 7n, but it's equivalent, of course, to minus 7n. And once you get it written in this form, I pull out what is common to 3n squared minus 27n, which is 3n, n minus 9. And what's common, 20n and minus 180 is, of course, 20. And I would need to multiply by an n. Remember, you always want to get these brackets the same. So n minus 9 is what you need here, which would make that a positive. That works out. You're on the right track then when these 2 are the same. So last step then, bring these 2 into the first bracket, and the repeated bracket is the second bracket. So now we have these 2 things multiplying to equal 0, which means that either 3n plus 20 equals 0 or n minus 9 equals 0. Solving this one, minus 20 to both sides, we get 3n is equal to minus 20, divide both sides by 3, and I'm getting n is equal to minus 20 over 3. Now straight away, I can see that there's no way we should be getting a particular term to be negative or even a fraction. It doesn't make sense in the context of patterns and sequences where the n always represents a particular term in the sequence. So that is not applicable in this particular context. So I can disregard that solution straight away. On this side though, I'm getting n is equal to 9, a positive whole number. That makes more sense in the context of this question. So I know that this is the answer I'm looking for. N is equal to 9.